Assalamu alaikum wa rahmatullah. Hi everyone. In this video, we will be working on another question from question 5 file of the coverage of a grade 11 elite for term 3. So we have a function f of x equals 2x e to the power of minus x defined for all real numbers x. Part A says find the equation of the horizontal asymptote for the graph of f. Well, the equation of the horizontal asymptote, it should look something like this. Y equals a number, right? Y equals a number. And to find the equation of the horizontal asymptote, you must find the limit of f of x as x approaches negative infinity and the limit as x approaches also positive infinity of f of x. So let's do that. So the limit as x approaches negative infinity of 2x e to the power of minus x. Here the limit as x approaches positive infinity of 2x e to the power of minus x. Now I like to rewrite those two limits like this. So the limit as x approaches negative infinity of 2x over e to the power of x, and this is the limit as x approaches infinity of 2x over e to the power of x. So I made the exponent positive by just shifting the e down in the denominator. So the first one, if you do it, it gives negative infinity. The second one is 0. The second one is 0 because the exponential is written in the denominator. It's stronger and it grows faster than the linear function 2x in the numerator. So as a result, it will be 0. So going back to part A, the equation of the horizontal asymptote will be y equals 0. This is part A. For part B, it says find the x coordinate of each critical point of f and then classify it as relative, maximum, minimum, or neither. So to do so, you must find the derivative of the function. So if you look at f of x, you have 2x, we will call it first, and e to the power of minus x, we will call it second. So if you differentiate the function to get f prime of x, you will differentiate the first, which is 2, leave the second e to the power of minus x, plus leave the first as 2x, differentiate the second e to the power of minus x times minus 1. Okay, so to find the critical point, you must set it equal to 0. Now let's first rearrange it. Okay, so we have e to the power of minus x in common, so we can factor it out, e to the power of minus x in common. That leaves us with 2 minus 2x equals to 0. We agreed that this one is never 0, so the whole bracket is equal to 0. That means x equals 1. And this x equals 1 is the critical point. We need to determine whether the function is having a relative maximum or minimum at 1 by investigating the sign of, you have to check the sign of f prime of x. Place the critical point here. Choose a value bigger than 1, like 2, that would be negative. Choose a value smaller, like 0. Substitute in f prime of x, it will be positive. Now, positive, it means increasing, negative, it means decreasing. So at 1, what do we have? We have a relative maximum or local maximum, because before 1 the function was going up, increasing, and then after 1 it's decreasing, going down. So at 1 there is a peak, we call it maximum, relative maximum. Part C, for what values of x is the graph of f concave down? Now to check concavity, you must find f double prime of x. So Let's work on part C. 1 second. Okay. Let's do part C here. We found f prime of x in the previous part to be e to the power of minus x times 2 minus 2x. Now to find the concavity, you must find f double prime of x. Differentiate the first, minus e to the power of minus x. Leave the second, plus leave the first, differentiate the second. The derivative of 2 minus 2x is minus 2. To find the interval of concavity, you must set this one equal to 0. Notice that there is e to the power of, or negative e to the power of minus x in common. Here I have negative, I have e to the power of minus x. I can factor it out easily, right? I can factor it out. So f double prime of x minus e to the power of minus x, that leaves you with 2 minus 2x plus 2. Set it equal to 0. So this is minus e to the power of minus x. 2 plus 2 is 4 minus 2x equals 0. This one is never 0, right? And the bracket can be 0. That means x equals 2. X equals 2. So after finding x equals 2, we will check the sign of f double prime. So if you choose a number bigger than 2, like 3, and substitute that 3 into f double prime of x, it will be positive. The second derivative sign will be positive, and if you choose 0, for example, that would be negative. What does it mean, positive? Well, positive means concave up, and negative means concave down. So the function is concave down for all x smaller than 2. For all x smaller than 2, or from negative infinity to 2. Okay? So the answer here is stating this one. For x is smaller than 2, the function is concave down. Well, the last part, part D, if we go back to the question, using the result found in parts A, B, and C, sketch the graph of y equals f of x in the xy plane provided below. Well, if you look at the part B, if you look at part B, there is a relative maximum at x equals 1. So at 1 there is a relative maximum. But what is f of 1? Well, f of 1, if you look at the function on top, it will be 2 times 1 e to the power of minus 1. That would be 2 over e. So it is somewhere here. So 2 over e as a decimal. Let me just double check. 2 over e as a decimal. 0.73, so it's slightly less than 1. It's somewhere here, right? So this is a maximum, right? And there is a horizontal asymptote at x equals, at y equals 0, and the function after the 1 is decreasing. So the function is decreasing and approaching the asymptote, approaching what? Y equals 0, the x-axis. Now, if you find f of 0, f of 0 will be 0, right? So the function must pass through the origin, and it's decreasing before the 1, right? So it has to be something like this. So this is a rough graph for f of x, according to what we got in the previous parts. Good luck.